Okay, so good morning, everyone. So we're continuing with revision for the exam, and we're still doing the main paper, and we're in question 8. So yeah, so we should finish the paper today. If there's still time, then we'll start with the SSA. So where we finished during the previous lecture was question 7. Where we basically had to identify a design pattern that was useful for a particular use case, and then we had to explain why the design pattern was useful and what the limitations of the design pattern were, right? So you should expect a question like that in the exam because we want to test that you're able to identify the correct design pattern for a problem. Okay, so in this question, so the story goes, why is it not zooming in? Okay, what? Okay, so I suppose this is as much as we can zoom in. So the question goes, as a developer of the utopian operating system, you want to ensure that every machine using the UOS is kept secure by always having the most recent version of UOS installed. So you want each machine that uses UOS to be notified automatically whenever there's an update ready to be installed. And new machines must be added to the list of machines that receive notifications about new updates, and machines may also be removed from the list of machines, right? So, the functionality can be achieved using the observer design pattern. So in this question, we tell you the design pattern that we want you to use in order to solve this problem. So in this case, the subject keeps track of a list of machines, right? So the subject is the UOS, and it keeps track of the machines that are observing the version of the UOS, right? And then it notifies the subject whenever there's a new UOS available. So what you need to do is provide a UML class diagram for the observer design pattern applied to the problem stated above. So as always, let's have a look at the observer design pattern. So that would be design patterns part 1. Okay, and that's the structure of the observer design pattern. So basically, we have an abstract subject, which in this case is the UOS, because that's the thing that is being observed, right? And then we have an abstract observer, which is all the machines that are observing the subject. And then we have a concrete subject, which is the concrete class. And then we have the concrete observer, which the concrete class representing an abstract observer, right? Most important thing is that an observer has a state and the subject has a state, right, of its own. So the observer updates its own state by observing the subject, right? And the subject state so every time it changes, we need to notify the observers, right? So the question even mentions here that the the subject keeps track of a list of machines, which it notifies whenever there's a new UOS version available. Okay, so let's draw the UML diagram. Okay, so the first thing that I would do is I would create the classes that are obvious. So we have an abstract subject, and then an abstract subject doesn't have any attributes, but it has a method for attaching an observer or detaching an observer. So attach, that would be abstract observer. No, so this is the return type of the method. And then, so, yeah, so let's just call it observer. Abstract observer. So you can name this class, for example, abstract machine. That's still fine, right? As long as you are indicating that it's the abstract class, or rather in this case, it's not the abstract class, but it's the interface. So detach. Let me just fix something here. Okay, just want to make the screen big enough for myself. Okay, so detach observer. And then we need to have a method for notifying the observers. Okay, and then we need to have an observer. So there's a question, if I write machine and not abstract machine, will I get penalized? Yes, you would get penalized because the machine, we gave it to you as a class. We didn't say that it was an interface, right? So you can't say that the machine is an interface all of a sudden, because in the question we said the machine is a class. Yeah, so and then update. Yeah, so that's the observer. You can show that there's a dependency. Well, let's make it in this direction. Okay, and then now we need to check the classes that we provided in the question. So in the question, we have a class called UOS. We have a class called machine, right? So the one thing that we need to keep track of here, so here we want each machine that uses this to be notified automatically when there's an update, a new update, and then they can also be removed by the, yeah, so you can see that there's a subject, right? So here you need to read really carefully. So there's a subject, and the subject notifies a list of machines whenever there's a new UOS available, right? Which means that the subject is not the UOS. Do you guys understand that? Yeah, so whenever there's a new UOS available, the subjects will notify the machines. So the URS is something that is contained by the machines and the subjects. Does it make sense? So the URS is the state of the subject, right? And that is the states being observed by the observers, right? Does that make sense? Okay, so then what we need to do is, so no information was provided on the UOS class. So all we know is that it's a state, right? So we just create a class, we call it UOS, and then that's that. So we know that it exists somewhere. And then now we create the subject. So you can call this concrete subject. That's fine. I'll just call it concrete UOS subject, just to make it specific to the fact that it keeps track of the UOS. So UOS, so that's the state that's being observed. So that's the name of the class. So here I'll just say operating system. Okay, so there's no need to show things like accessors and mutators in this diagram. So we just need to show that it overrides the attach method. No, man. This, oh yeah, but so what other attribute do we have in the subject class? So remember, go back to the question. It says the subject keeps track of a list of machines, right? So that's another thing, right? So we need a list of machines. So then we go back, and then we call this machines. And then you can use an array list. You can use anything you want. Okay, so those are the attributes. And then we override the methods from the interface. And we need to provide a parameter. And notify observers. Okay, so that's the subject. Implements the interface. Yeah. Okay, so that should do it. So this, so if you look at this, so we notify the machines, right? Whenever there's a new UOS available, and new machines are added to the list. So clearly the machines are the concrete observers, right? So machine concrete observer. Attributes, remember an observer has a state, right? So the observer state in this case is the current version of the UOS that it has, right? So then current operating system. So to make this like a bit easier for you guys, this year in this type of question, you also receive a piece of code that kind of gives you more context, right? So you don't have to read the question many times to try and figure out what's going on, but you still need to read the question properly and really think about it, right? So think about what role each class is playing in this whole scenario, right? So you need to do that. You need to think about that. Okay, so this will be the UOS. And then we need to override the update method. And that's the machine. Okay, and then so in this case, we have an array list of machines in the subject. Then clearly what we need is to show an aggregation relationship. Okay, so that should do it. And then both of these have an instance, albeit not the same in the sense that the operating system on the subject will always be the latest version, and the one on the machines will always be the one that has to be updated, right? So, but they both contain an instance of UOS. So, some more aggregation. Why do you hate me? Okay, there we go. Okay, so that's our UML diagram, right? So what do you receive marks for? So you receive marks for your classes. If you have the abstract subject, get a mark. Abstract observer, you get a mark. Concrete subject, you get a mark. Concrete observer, you get a mark. UOS class, you get a mark. And then concrete UOS subjects, the implementation relationship, you get a mark. Observer machine, you get a mark. Having the collection of machines, you get 2 marks. Attaching a machine, you get a mark for that. Detaching a machine, you get a mark for that. Concrete observer machine update method, you get a mark. Having an instance of UOS in both classes, you get 2 marks for that. So eventually that becomes 15 marks, right? So that is how we typically mark this question. Okay, so that is that. Any questions regarding this? Okay, so let's move on. Okay, so let me just check for questions on Blackboard. No, so the machine does not have like an attribute representing the subject, because the subject already has a list of machines which it notifies, right? So there's no need for the machines to have a reference to the subject, right? So yeah, so that's also how the design pattern is implemented in the lecture slides. Okay, so that's the UML diagram. Cold code section. Okay, so here we have a question where we have to provide code. So provide Java source code for the following problem. So you can assume that all relevant packages have been imported. The Utopian Farming Organization has tasked you with updating a program that keeps track of livestock data. So we have that. So the update required is to, yeah, so the program already exists. So you need to change it by recording livestock data into a text file. with a specific format. So at the moment, UFO keeps track of two kinds of livestock, cows and chickens. Some of the code available in the program is shown below. So we have livestock, and then we have an ID, we have a weight, and then we return the ID. Yeah, so those are accesses for that. Rest of class omitted means that you do not need to know about the rest of the class in order to answer this question, right? So the code we gave you here is enough for you to be able to answer the question completely. So we have the cow class, then we have that. Chicken class, we have those methods. So what do we need to do? Create a static, record cow info, right? So we need to record only instances of this class, right? And the method accepts a file handle is a, and an array list of livestock as parameters. So the array list of livestock can contain instances of both livestock, right? So what this means, instances of both subclasses. So it can contain instances of cow and instances of chicken, right? So, but we want to write cow info only, right? So we need to record cow data to a text file, and we need to use automatic resource management. So the structure should be as follows. So we print the ID, comma, height, comma, milk produced. So it's basically a CSV type of output. Okay, so let's do that. Yeah, what happened now? Oh yeah, I can. Okay, so let's do this. Okay, so what do we need to do? So the first thing we need to do is we need to create a print writer, right? And we need to use automatic resource management. And if you create a print writer, there's a checked file not found exception. Okay, and then so after that, what we need to do is we need to basically iterate through the list. Oh yeah, okay, so that's fine. Okay, and then unfortunately, this is not a countable noun, so this can be confusing. But yeah, so that works. So now what we need to do is we need to basically check. So we're only printing that. So what we need to do is we need to format our string. And we need to print the, how many things do we need to print? 1, 2, 3. Okay, so and then we need to skip a line. Well, we can do that with the print writer. And then so we need to provide the, oh yeah, so we need to do this. So and then we need to get the, I think it is the ID. The second one was weight. Let's just check if so let's just double check here if the methods are correct. So get ID, get weight, get more produced. So that's the exact same names of the methods. And then, so after printing that, then, okay, so we need to write that to the file. So print line. Yeah, and that's literally all you need to do. Yes.
Sure, you should press file not found exception or IO exception because it's not exclusively file not found. If the file's in use, this will fail.
Yeah, so if okay, so that is true, but remember the IO exception is not checked for this particular use of the print writer. So specifically, at minimum, what you should catch is the file not found exception. But if you did catch the IO exception, you would still get your marks. So that's completely fine. You can do that as well. Yeah, that would actually be better in practice, but at minimum, you need to catch the found and found exception. Yeah. Yes. No, you would not get the mark because you do not know what you need to catch. Right. So exception is like, well, I know I'm supposed to catch an exception, but I don't know what it is because I did not study. So we would not give you a mark for that. But IO exception, yes. Found and found exception, yes. Okay. Yeah, so how do we allocate marks for this? So let's check. Okay, so method prototype, this part, you get a mark. File, so let's just do this. For taking the file as a parameter, you get a mark. For the array list of livestock, you get a mark. And then print writer, so you get a mark for creating a print writer, and you get a mark for using automatic resource management. You actually get 2 marks for that. And then you get a mark for the loop. And you get a mark for checking the instance of. And then you get a mark for creating, so casting into the actual instance that you're looking for. You actually get 2 marks for that. And then creating the output format, so formatting your string as required, you get 2 marks for that. And then, so printing, writing correctly, you get a mark for that. And then you get a mark for catching the exception. Yeah, so how many marks do you get? So it should be 15 in total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right, so even if, let's say, for example, you did this part and you did not do that, right? You still get 1, 2, 3, 4, 5, 6, 7, 8. That's more than half of the marks, right? So you literally get more than half of the marks just for having the surrounding code, right? Without doing the actual writing to the file, right? So please do not panic to the point where you don't answer the question, right? So try to answer the question because chances are you will get some marks for it. Okay, so that's the main paper. So let me try and find the SSA. And then so I'll have to upload it to Eve after the lecture in order to save time. Here, so SSA. Here. So same stuff. Yeah, so question 1. Okay, so here, instead of having like your normal Java question, you had to answer a question about Javadoc. So Javadoc is a unique documentation mechanism in Java. So question 1A, discuss how writing Javadoc comments is different from writing normal Java comments. So you basically need to compare how they are different when you are writing them in code. So who wants to try? Yes. Yes. Yes, that is.
Parameters and they normally describe both the parameters and functionality of the underlying functional method or class.
Yes. Yeah.
They also provide, once you use the Javadoc creation tool,
yes.
Creates a documentation index used as visual.
Yes.
Be present in the actual source code.
That is 100%, right? So first of all, Javadoc comments are parameterized. That is true. And secondly, you can specify the difference, like they help you describe the method, so what it does, right? So helps you describe methods, classes, and attributes. They help you describe your parameter list. They help you describe your return values, right? Another thing you could mention is that, so this is very simplistic. So you guys wouldn't think of saying this, but you would get marks for it because it shows how Javadoc is different from normal comments. Normal comments, you use this, Javadoc comments, you use, let's go all the way, you use that, right? So you get a mark for that as well. You also get a mark so you can also indicate things like tags, right? So you can provide things like links, You can provide things like versions, you can provide things like author, and so forth, right? But the most important thing is for you to mention 6 facts, right? If you mention that, so actually you don't have to like go all the way. So let me look at the mark allocations for you guys. Yeah, so we gave you 2 marks for each fact. So if you mention 3 facts, you're done, right? You didn't have to go through the trouble of mentioning 6 facts. So you can mention any of 3 of any of this, and you would get all your marks. Yeah, so that's how they're different from normal Java comments. Okay, so what is the process of compiling Javadoc? So your discussion must include the command line tools and the inputs and outputs of the tool. So that is in your batch file, right? So unfortunately, because this is not a practical test, you will not have a batch file. So you need to remember this off by heart, right? But what is the name of the tool that we use to compile Javadocs? Not Java P. It is not Java. So Java P is for decompiling a class file into bytecodes. So if you want to view the bytecodes, yes. Java C is for compiling. I can't believe you guys can't remember this. It is so easy. It's Javadoc. That's the name of the command, right? So that's the name of the command. What is the input to Javadoc? What does it take? What's the main thing that it takes? So in your batch file, like we specify all sorts of things like your source path, your class path, the package that it needs to start, and then we specify sub packages, which means that it needs to look at every other package that's inside of that package, right? But what is the main input for Javadoc? It's the same input you provide for Java C. It's your source file, right? Javadoc takes source files as input, and what does it provide as output? Provides HTML files, right? So when you double click on the HTML file that is an output for Javadoc, then it opens on a web browser, right? So you can just say it outputs documentation that can be viewed using a web browser, you get a mark for that. It outputs HTML files, you get a mark for that, right? But the main input to Javadoc is the source files. The outputs are the HTML files, right? How is the mark allocation done for that? By mentioning the tool, right, which is javadoc.exe, you get 2 marks, right? And then by mentioning that it takes in source files, you get 1 mark. By mentioning that it outputs documentation, you get 1 mark. Okay, so that's the whole idea. Okay, so yeah, so we'll do this on Monday. Yeah, we'll finish this. But yeah, so thank you very much. I had more interaction from you guys today, which is good, because this is revision, right? So enjoy the rest of your day and finish your bonus practicals and your practical X. Yeah, thank you. Yes.
My practical design has been someone, they're still marking.
That is weird.